Hey everyone, this is SManiar speaking, and I had a discussion with Guggen yesterday, and he asked if I could just demo some of the AI initiatives I've been working on, some recent projects. And so I'd like to showcase three quick examples of what I'm working on. One is something that I've developed on Bolt.New, but I'm going to highlight some interesting concepts behind that, something about a workflow in N8N, and then lastly, this aspect that I've been using Claude in the VS Code here on some optimizations for research and PRDs and how there could be a good use case for Maven. So here what I have here is StormShield, and it's solving a problem I always wanted to solve, is weather along the way. Sometimes when you go on a driving vacation, you have to look up multiple times the weather in different locations, and it's not there in Google Maps or Apple Maps. So I said, hey, I'm going to go ahead and do this. And one of the key things was, if you think about the output of replete, Vercel, and all those things, it's pretty generic, and you really have to work hard to make it really nice. And what I did was I attended some design firms, UI UX firms here in San Francisco, and got to learn some advanced techniques and skills on what UI UX designers, and they shared some of these, and I started tweaking them to get a much more robust, not only design, but then UI and UX flow in trying to minimize this. And the second thing, the thinking behind this, is there's this concept called here, it's called vertical slicer. What vertical slicer is some top product leaders put some thinking into really cutting down features into very quick, actionable actions. And through that process, you feed it through, and then whatever idea you have here with this weather route, I put in the high level. It just really gives you a good sequential, very robust querying context that you can put into any system, whether it's Vercel or Bolt. So you get a much more better design and a faster design that works. So that's how I developed this StormShield. And then let's pick a route from, let's say, Oakland. I think Guggen is based in the East Bay, and let's pick a route to Tuscaloosa. I don't know, somewhere across the country, Tuscaloosa. And the probability in springtime, I'm sure there's going to be storms along this route. And so right now it's querying it. It's giving, weather along the way. I had to do some optimization to figure out the trace routing on the API endpoints. And then additionally, I came up with some math and logic to figure out how risky it is using some various research I did and everything. And it's showcasing that it's a moderate risk. And there's a heavy storm expected at hour 10. So you could see how the weather is going to change as you drive 2 hours out, 4 hours out, and what have you not. So very useful use case. And I'm going to be iterating and optimizing on this. So that's one example. So, another thing that I did here was I also noticed the latency. The latency used to be really slow, and then I optimized in trying to, instead of doing sequential based API calling, I asked, and I figured out a way to do parallel API calling so it reduced the latency by at least 70 to 80%. And so these are some of the thinkings that can go through with respect to the product. So I just want you to be aware of that. Now here, this is N8N. Many of you might be familiar with it. It's like a modern version of Zapier and mapping into workflow, and it really works well for workflow automation. And the use case here was I was helping a colleague out set up some not only visualization, but a working solution that he could then demonstrate to his colleagues at Coinbase, because there's a big problem with KYC AML. What the situation is, it takes about 2 hours to verify someone due to all these requirements that are happening by various governments to approve someone for a crypto account. And even on the corporate sector, anyone on that team, every single person, not only locally, but on a worldwide basis, has to be verified that not any one person or entity is on a sanctions list. And so it's a very complex situation where it takes 2 hours to really verify that a person says who or they are. So what I did here was I built an orchestration agent, and I really will. So let's put in a name here. And this person was, I just saw in the news that he could be a bad actor. And what this agent is going to do is the orchestration agent is going to reason, or not necessarily reason, but it's going to call the different tools. And I also made each sub-agent a tool. One is a name matching agent, because sometimes if there's 25 John Smiths in Dublin, how do you know which one's going to be a bad actor? So there's a sequence of calling in the instructions, look at LinkedIn, look at all these other parameters, look at news, look at all these aspects, and return a match. And then the screening agent will then contact various databases where I did some API integration. Now, usually for each country, there's probably about 8 or 10 different databases that need to be matched into this, and then it's a much more robust thing. But this is just to demonstrate the concept of how powerful AI can be in reducing work complexity and coming up with an output. The other thing I will showcase here is one of the key takeaways for each of you is, and one thing I've learning with my colleagues and everything is, you could point RAG and all these other tools to modify the agent, but lately what's been happening is if you do iteration and then improve the context or the Claude.MD files or various MD files or the skills and really compress it, the robustness gets better and better. So this is why you don't have to think about all these other complexities. The other thing is I figured out initially I had 30 turns or iterations. I may bring it down to 15 to reduce the costs on token processing, but there was some optimization here, adding memory. I looked at different models. So basically this returned here is, there is a better UI I can show you on the output of it, but just for a quick recording, it shows a 95% match of Denis Igorovich Gusev and very strong. And then it also found another one with the same one, a name, and that said this person could be 70%. So it could tell, it also says maybe you might need to do a little more investigation, but it looks like on the very 70 and 95% that there's a high risk that this person is a bad actor, and there's a match on the OAF AIC tool. So this reduces maybe out of that 2 hours of research, maybe 25 minutes, 15, 25 minutes, and it's a great use case. Now the third thing I'd like to highlight is specifically this VS Code version where I've Claude installed both. Here's the GUI and here's the command line. And the key takeaway here I wanted to do was there's a lab that I actually was part of that I went through the lab about 2 months ago, and I really went through the sequencing and I learned the parameters from it, but then I optimized it. And the key takeaway with this is you focus on, let's say, a company or user cohort research, then you do additional user research, you do competitive research, and then you do market research, and then you come up with not only a product requirements document, but the key takeaway is the Claude.MD. I sequenced it such that you optimize the Claude.MD, or I told Claude to optimize from the outputs what it saw from each instance, and then it became a much more sharper. I also incorporated customer feedback and some of those components, and I say, hey, because AI can only take from the internet, but if you take actual feedback from customers, it then optimizes on that. So it really makes it a much more robust thing. And the use case I could think of for Maven is Guggen and I discussed those certain cohorts. There's power users who are earning X and another set, but how do you get maybe the second or third set to really adapt? And maybe this modified version of this could give a much more robust output or thinking or for development in the product much more quickly. So these are some of the examples I'm highlighting, and have a good day. So thanks a lot.